Good afternoon, everyone. I hope our lovely lunch isn't going to put you all asleep, for my presentation at least. So my name is John Wood. I am a technical diver, and I specialize, if you like, in creating 3D models of shipwrecks and sites underwater as a volunteer for Heritage Malta and University of Malta. And I'm going to be talking a little more in depth about the process of gathering the data and processing that data to create the 3D models that we create. So, as Maya explained quite clearly, the use of the 3D models that we create is applied very much to two aspects, if you like, two dimensions. One is for public outreach purposes, as we have on our left-hand side, the virtual museum. But more and more, we use the data for technical documentation of sites, whether it's a one-off study of a newly discovered shipwreck to actually document what's been discovered, whether it's to monitor changes on the site, which could be due to various factors, maybe environmental degradation, maybe damage from surface vessels, maybe vandalism and looting, which unfortunately happens from time to time, though since I think the management system has been put in place, much less so. And also to document excavations. The teams I work with do regular excavations on sites in order to understand further, especially on prehistoric sites. Photogrammetry is used extensively for that purpose. Now, there are two main methods of gathering the data. We talked about human diving, which, as Maya said, takes us up to a maximum of 120 meters. And soon we'll be embarking on some tests using cameras and lights on our AUV. So I'm looking forward to that more dry experience in gathering data, and that should be quite an interesting journey. However, even just diving to 100 meters plus isn't a trivial undertaking. It requires years of training. It requires a significant investment individually in very sophisticated equipment. So, and that's just to reach 100 meters. We do more than that. We run projects, we run excavations, we do tasks, we do scans of objects, of shipwrecks at those depths. So that it becomes even more challenging, but obviously safety remains always a big priority for us, and I think in that respect we have an excellent track record. So yeah, the challenges, I suppose, when compared to land-based 3D modeling or gathering of data for 3D models are many. So the safety issues I mentioned earlier, but also things like limited time available at the target depths. The deeper the site is, the less time we have. I mean, if we're on land scanning this room, you could spend 3 days in it very comfortably doing each corner. When we're underwater, there are limitations in terms of how long we can spend underwater. If it's a deep shipwreck, then literally sometimes we limit it to minutes, 10 minutes, 12 minutes every dive. And then we have to go back the next day, and again the next day, in order to gather more and more data to gather the data we need to build the model. Visibility is many times a challenge underwater. As you can see from the right-hand side image, that's during actual excavation. But even with fish farms now, more and more fish farms, some wrecks have become very, very difficult to dive on because of the visibility issues that we have. Therefore, the photographs you take aren't going to be very clear. Therefore, you have to dive closer to the wreck. And the closer you have to dive to the wreck, then the more data you need in order to get the data to make the model. So all these challenges. Equipment is more specialized. So while we might be using the same cameras that are used on land, they need to be housed in specialized housings, which can survive at the depths we dive at. And also, it's very difficult to benefit from technology like global positioning. So there's no GPS signals underwater. So it's not like you have a drone here where you can track where the drone is and use that data to help in the 3D modeling. Underwater, it's a totally different situation. So to my next slide. Here we're going to see the same shipwreck that Maya talked about, the Kuyawak. This is a ship, as she said, sunk in 1942 during World War II. It lies at just above 100 meters, 98, 97 meters is the seabed. And the length of this ship is 85 meters, so quite a big ship. We scanned this in 2023, it was. Now, to create this model, it's not perfect. It'll never be perfect. We'd have to go again and again and again. But we do enough until it's good enough, if you like. This took 10 dives with teams of 2 people each dive. Each dive was around 3 hours long, and in a couple of cases, significantly more. We gathered 14,000 images in order to create this 3D model. So a 3-hour dive actually only gives us between 20 and 25 minutes actual working time at the bottom. The rest is spent in decompression. So if you count that, if you count the backup team who have to support the divers who are diving deep, gathering the data, you have to count the processing. Quick back of an envelope calculation gives me at least 30 man days to gather the data and process the data into this 3D model. It's apart from the cost of the boat and the equipment and the gases, et cetera, et cetera. So it is quite an undertaking, and this is why the deeper the wrecks, the bigger the wrecks are, which need to be added to the museum, then they just take the time they take. There's no way we're going to be adding 3 or 4 a year, for example, because each one of these is a major project in its own right to do. So here we see maybe a bit more detail of the model in the actual software. We use a software called Agisoft Metashape to do this. Each blue rectangle you see in the bottom image actually represents a photograph. And there we can see also on the left-hand side a bit of detail of the hull, of the bow, showing all the different photographs which constitute that particular area of the model. So it gives you some idea of the scale of things we need to work to. And this is just one image from the set of the 14,000 images which we used to create this 3D model. And you can see the kind of quality, if you like, or lack of quality of the image. And that's probably quite a good image, actually, to work from. So it's not an easy task, even when it comes to the processing side. So as we progressed our work from shallower depths to deeper and larger wrecks, we needed to think a bit out of the box and work to improve the speed and quality of capture, always keeping in mind safety issues. So nowadays, to most of our work, we use cameras which are mounted on underwater scooters, which, as you can see there in the image, that's on the actually tower wreck, which Rebecca will be talking about later. So the scooter pulls the diver along the sea bottom. There's a camera mounted to the front with lights, and the camera is just taking photos, one every second or one every half a second, and kind of imagine the land equivalent is like a drone flying above a site, taking photographs. We've also, a couple of years ago, started using a system like you have in the top right-hand corner, where we have 3 cameras actually on a rig, and 2 of those are synchronized, taking photographs together in synchronization, what you call a stereo pair of cameras. And that gives us the ability to create scaling of the model, to actually measure what we're modeling without actually needing to lay scale bars or taking physical measurements from the site. And that's helped a great deal. Helped to speed up data capture quite a lot, because it saves the whole process of putting scale bars down on the site and picking them up after once we're ready, assuming we want obviously to scale the site. But photogrammetry is a lot more than, as I mentioned earlier, a lot more than pretty models. In fact, the word photogrammetry means measuring through photographs. So the concept of using a 3D model to make measurements which mirror as far as possible the physical reality of the site is also very, very important. In fact, we've developed a methodology where we use photogrammetry also to document excavations. And certainly this is a far more efficient and accurate method of documenting excavations than more traditional methods using scales and tape measures underwater and this kind of thing. So here we see an image from the Salini excavation. This is quite a shallow job. This is at around 4 to 5 meters in Salini Bay. And this is a yearly undertaking by the University of Malta, and it's used to train students in underwater excavation techniques. And we use that process to mentor students and to teach students how to use photogrammetry to do this documentation. Here again, we're seeing 2 images of the trench. This is actually from this year's project, which was closed today. Today was the last day of this project. I don't know if any of you drive by Salini, you'd see a big white marquee and lots of people running around over there. That's actually the students running this project. So that's the trench, which is excavated down to a depth of around almost 7 meters, so about a 3-meter deep trench, so quite deep. And the blue lines you see there are the photographs which were used to make up that 3D model. And the outcomes we get from this work allow us to do many things. We can measure, for example, there's a piece of timber there which was discovered on the seabed during the excavation, where you can measure that virtually. You can create cross-sections of the trench, as we see in the photo next to it. And you can use daily models to compare progress and to document. So here we're seeing, for example, what we call a digital elevation model showing actual depths of the site, and another one comparing one day with the previous day, showing the areas of the site which have actually changed since the previous day. So it's a very powerful tool for this technical documentation. We also use the same methodology on deeper sites. This is a totally different kettle of fish. This is the Phoenician shipwreck of Schlendi and Gozo at 108 meters. And there's a diver creating a daily photogrammetric model of the excavation area. The limiting factor, as I mentioned earlier, with this kind of dive is the time we have on site. So each dive gives us just 12 minutes on site to create this 3D model, to gather the data to create the model. We've run 4 seasons of excavation on this site between 2018 and 2021, and now that's a project which is closed. So just my last couple of slides give you an example of the outcomes of the photogrammetry on the Phoenician shipwreck now. This is the site. It's 12 by 5 meters, and as you can see, there's a large number of amphora and grinding stones at both ends. And the excavation took place in a small area towards this side of the wreck. So this is prior to any disturbance, and this is how we left the site in 2021. So you can see that section which has been excavated totally, but allowing us to take 4 years of photogrammetric data and overlaying gives us the ability to visualize the site like this, for example. So this is effectively a heat map of the changes to the site. Anything blue hasn't been touched, but there you can see clearly on the right-hand side a scale showing the color changes which relate directly to the depths or the amount of changes that took place on the site. So that's me. Thank you very much. I hope that's been interesting, and I'd welcome any questions afterwards. Thank you.